And then what we're looking for is the greatest common factor in each set of parentheses. Okay? So if we do that, greatest common factor in the first set of parentheses, we can pull an x squared out, which means left we have x plus 3. In order for factoring by grouping to work, you have to be able, when you factor out the greatest common factor, you have to get the same thing in the parentheses. Okay? Otherwise it doesn't work, which leads into today's lesson. What happens if you've got 4 terms and you can't do it by factoring by grouping? Then what? Long division, synthetic division. Now that's where those come into play. Okay? So what do I need to factor out so that I end up with an x plus 3 inside the parentheses? A negative 9. Yep. Pull a negative 9 out of that. That'll leave me with x plus 3. Okay? So now we have factored that cubic function into 2 factors. One factor is what's in parentheses. That's why we need it to be the same. So one factor is x plus 3. The other factor is the stuff we factored out. The x squared minus 9. And now from here, we take a look and we keep going to finish off the zeros. The second factor happens to be a difference of squares, so we can factor that. So we've got x plus 3, our first factor. If we do the difference of squares in the second part, we end up factoring to x plus 3 and x minus 3. And now, if we take a look, now we go to the zeros. Notice, I have 2 of the same factors. So one of the zeros is x equals negative 3. What do I know about that 0 since I have 2 factors that are the same? It's a double root, which tells me what on the graph? It touches the x-axis and then goes back and just bounces off. Okay? So there's your first 0, which is a double root because we've got 2 factors, which tells me it bounces off of the x-axis at negative 3. The other 0, which is a single root, is x equals 3. Okay? That's the other root. We have a total of 3 zeros because it's a cubic function. 1 double root, 1 single root. There's your 3. So now if we go to actually sketching the graph with some actual values here. By the way, I said at the beginning of this, there were people that were turning in not very much stuff. Here's what I saw, by the way, to give you a heads up. Okay? So don't do this today or in the future. I saw that. One 0 is x equals negative 3. The other one's x equals positive 3. And there's my function. That's what they turned in. I say they. It might be you. Look at all the work that had to go into this to get to those zeros. Okay? Come on. You got to be able to do better than that. Let me write down the answers from the back of the book, throw together some crappy graph, and call it good. Next problem. Okay? Come on. So, let's fix it. The whole purpose of finding all that stuff is at negative 3, let's put that in there. At positive 3, let's put that there. We've got zeros in those 2 spots. We said we already talked about the shape of the graph being a positive cubic function. And because negative 3 is a double root, it's going to come up, bounce off of the graph at that point, and then go back up. There's what your graph should look like. Okay? It's still a sketch, but it's a much better sketch because we now notice the double root, the single root. It's got some specific points on it. Okay? Make some sense, hopefully, Alex?
Could you scroll up to the word really quick?
Yeah, you bet. That part.
Can you do that part where you do
So
you know, when you do the infinity to...
Oh, and behavior?
Yeah.
Sure. On this one?
Yeah.
Sure. Let's take a look. Question, Alex?
Because that's not in the
Does one
book.
of the
Okay,
x
hang
plus
on.
3 just so they just combine
I don't know.
to the same thing?
To go from here to here?
Yeah.
Is that what you're saying? Here's what's really happening. I didn't explain it because it's kind of hard to understand. But you know how we factored out an x squared? What you're actually doing is factoring out the x plus 3. If you look at that as one term and this is another term, you're actually factoring out the x plus 3, and then you're left with, you're doing it again. You factored out, and then you factored out again. Does that make sense? If you can kind of see it. That's why these are the two factors. So if we add in, let's say we add in some end behavior just for some practice, because again, that's something we've been working on in terms of the x going to infinity, negative infinity. If we have this as a graph, as x goes to negative infinity, where is y going? As x goes to negative infinity, as we go to the left, the graph is going down to negative infinity. Okay? And again, remember, don't go rise to the left, that kind of stuff. I want you to use this form instead, okay? As x goes to positive infinity, where does y go? Yeah, as x is going to the right, positive infinity, the graph is going up to positive infinity. So there, that would be the end behavior that fits with this graph. Okay? Yeah, right?
Under the test, do we need to include like the theoretical y-intercept?
If I ask you for it. Yeah, I'll be specific. I'll ask you for the y-intercept. And when we start putting things together, that's probably a point we'll add in. Right now, I'm mainly looking for the x-intercepts in a general sketch. Okay? I wouldn't be upset if you put it in. But right now, if you don't, I'm okay with that. Okay? Okay, Preston, you had said 77, right? Perfect, because that's the next one I have. All primed up here and ready. All right, so let's take a look at 77. Same idea. We're still sketching, factoring, finding the zeros, still the same concept, but different type of problem now. First question, before I start at all, what's this graph going to look like? W or an M? Which one? Yeah. Fourth degree, that's why it's W or M. Negative 1/4 for the A value, so it's opening down. This will be an M. Okay? Again, I need to go through and find the zeros, which means I either need to factor a quadratic formula. I'm not using the quadratic formula. And to be honest, right now, because of that negative 1/4, I don't really like the factoring option either. This is factorable, by the way. Okay? Again, one of the things you need to be able to recognize is whatever the degree is for your leading term, if the next term is half of that and then you go to a constant, that's a quadratic type of equation. Just like if you had an x squared, then an x, then a constant. It's still a quadratic, just I've basically doubled everything. Okay? What I don't like about this one is I don't like the negative when I'm trying to factor or the 1/4. So how can I take care of both of those issues in one step? Multiply everything by -4. That'll take care of both of those issues. So 0 times -4 is still 0. When I multiply by -4, I get 1 here, so this is just t to the 4th. Times -4 gives me -8t squared. Times -4 gives me plus 16, and that's a lot nicer than what we started with. Okay? Now let's factor. Factors of t to the 4th, t squared and t squared. Factors of 16 that add to -8, -4 and -4. And if you notice, now, we have the same factor twice, but both of those factors are also difference of squares, which means I can factor each of those. So we end up with t plus 2 and t minus 2, and then we have it again, another t plus 2 and t minus 2. Okay. Which means we have 4 total zeros. We've got 2 of these factors, t plus 2. There's one double root at t equals -2. And we've got 2 more factors that are the same. So you have a second double root at t equals 2. So you only have 2 numbers, but they're both double roots, which is why it's still a 4th degree. So now if we put this together, again, as we put it all together for a graph, the sketch, the zeros, the double roots, all that kind of stuff. We said originally this was going to look like a W, or excuse me, an M that's opening down, okay? We have, let's call that -2, let's call that +2. There's your zeros, which means if it's opening down, we're coming up, double root, bounces off, changes direction, back up, bounces off, and there's what, in general, your graph would look like. Okay? doesn't go through the x-axis at all, bounces off in both spots since they're both double roots. How we doing, okay? Getting the idea? And like I said, I'm hoping you're starting to see why, like I feel these problems are super important because there's a lot that goes on in these problems with the factoring and finding the zeros and the double root versus single root and the shape of the graph and the end behavior and all of that kind of stuff. There's a lot going on. What we've been talking about is starting to come together, okay, in these problems. That's why I mentioned at the beginning again, don't just put together some crap on a page, okay? This is important. This is important that it's starting to come together for you, okay? Any other questions that you want to go over, or are we ready to go into the lesson? What we got? Doing okay? That should hopefully clear some things up, hopefully, for those 70s. All right, let's go into the lesson then. So here's our lesson for today. Today is long and synthetic division day. Again, I still don't have any, I think I told you this before, I still don't the whole week I haven't had any daycare in the morning for my kids. So once again, my kids were here this morning, first hour, and then I took them to school second hour. The reason I bring that up is my 5th grade son right now is currently working on long division. Okay? One of the examples I'm going to give you, I probably could have brought him into my first hour class and said, hey, how do you do this? And he could have gotten through the process with numbers at least, maybe. Hopefully. I don't know. We'll see. Not quite sure where he's at, if he gets it yet or not. But I noticed his homework this week, he's been bringing home long division. Okay? And we're going to go back to that concept today. Here's the number one thing you got to understand today before we even get started. Long division and synthetic division are methods of factoring. That's what we're doing. Okay? If the other methods of factoring don't work, that you don't have a difference of squares, you can't just factor like a quadratic. There's no greatest common factors. We can't factor by grouping. If all those are, you don't have them as options, you can do long and synthetic division. Okay? And that's the number one thing you need to know. So, I was telling you before, you don't have to write these down. This is just to give you a heads up. So here's a couple of problems right here. Okay? We're going to do these by long division. Okay? First off, by the way, or I'm going to show you the long division process again that you learned in 5th grade. Okay? Here's what it looks like. So the 28, again, you don't have to write this down. Okay? Don't worry about writing this one down. Just pay attention on this one. So we're taking the 28. Okay? That's our dividend. That's called our dividend. The 4 is our divisor, what we're dividing by. And here's the process. This one's a quick one, but here's the process. You look and you say, all right, does 4 go into 2? No, 4 doesn't go into 2. So then you add a next number. Does 4 go into 28? Yep, 7 times. And then 7 times 4 gives me 28. And I subtract, and it turns out I get 0. That 0 is called the remainder. And if I have a remainder of 0, what does that tell me about what I divided by? That it's a factor. Yep, that it divides by that number, that it's a factor. Okay, that's exactly what I was looking for. If you get a remainder of 0, that means your divisor was a factor, which you already knew. 28 divided by 4 goes in nicely. Okay, but here's the kind of the process. The other part that I want to make sure you understand is if you take the divisor and you multiply it by your quotient, your answer that you got, you should get that back. 4 times 7 should give you that. Okay, so these would be your 2 factors to get this 28 back. That's what this is saying, by the way, right here in the green. So if I give you one that's not as nice, okay, one that does not go in and will have a remainder, if you take a look at this one, same starting point. Does 9 go into 2? Nope, that doesn't work. So then we go, does 9 go into 28? How many times? Yep, goes in 3. 3 times 9 gives me 27. I subtract. I got 1. And if we wanted to go to decimals, we could say 0.0, and then we'd bring the 0 down, and we'd keep going. Okay? In this case, we ended up with a remainder of 1, which tells me 2 things. 9 was not a factor of 28, because we have a remainder. And if you wanted to write the remainder, you always take the remainder over what you divided by. That's where this 1/9 is coming from. So 9 goes into 28, 3 1/9 times. Okay, so that's that's the process. Okay? That's the idea of what's going on. That's your process. Here's kind of a little bit more formal. Here's where you should start taking notes now. And then we'll get into some examples so you can see it at work. Here's the general layout of the process right there. Okay? A little bit of vocabulary here as well. Whatever function you're starting with, in this case, for me, it was the 28th on those last ones. That's called your dividend. You're going to be having an actual cubic function, quartic function, whatever, quadratic. You'll be having something like that. What you divide by is the divisor, and the answer you get is called the quotient. And your process, as you work your way through it, kind of like we just did, you figure out, all right, how many times does the divisor go in? You put that answer up top, and then you multiply and subtract. Multiply, subtract, multiply, subtract. That's the process until you get to some remainder. Hopefully it's 0. Sometimes it will be, sometimes it won't. And the other thing I want to make sure you know is those two parts right there. If you take the divisor and the quotient, those are your two factors that will multiply to give you the dividend back, what you started with. Okay? That's why I said this is a factoring problem. There's your factors that give you that. Okay? Divisor times quotient gives you dividend. One quick thing, and that, by the way, what I just said, is you don't have to write this down, but that's what this means. This is the mathematical way of describing that to get your function, take your divisor times your quotient, okay? And if you multiply those back, that's all this is saying. One quick heads up that you'll see in a couple of examples coming. If you're missing any terms in your dividend, okay, if there's any, so for example, here's what I mean by that. Let's say we have a cubic function, which normally means you'd start off with some x cubed, then you'd go to something x squared, then x, then constant. If you're missing any of those, you have to fill in with zeros as like a placeholder. Okay? So let's say I was missing the quadratic term, the x squared. I'd have to plug in plus 0x squared underneath or in the dividend. Okay? And like I said, I'll show you that. I've got at least one or two examples where that happens, so you can see what I'm talking about. Okay? Are we ready? Here we go. Example number 1. Okay? It's the same every year when you have long division. Ugh. It's not bad. It's not as bad as it looks, Preston.
No,
Oh, this time you agree with
I can
me.
agree with it.
This one you agree with. All right. So just a heads up on this one again. Hopefully you saw this last year. I know I spent a day or two talking about it in my Algebra 2 class. I know that Mrs. Geyer did. I don't know otherwise. I'm not sure. Okay? You did? Okay. That part I just don't know. I know you did synthetic division. I'm just not sure if the long division was there or not. Okay? So here's the process. Okay? Let's take a look. So if we set this up, first of all, as a long division problem, we're dividing by 3x minus 2, so that's on the outside. And our dividend, in this case, is that cubic function. 6x cubed minus 16x squared plus 17x minus 6. So there's the setup. Here's what I was getting at, by the way, again with the zeros. Notice how I have an x cubed, I have an x squared, I have an x term, I have a constant. I have all the terms in order. If any one of those were not there, I would have to fill in with a 0x squared or a 0x. Okay? All right, here's your idea. When we do this, what we're trying to find is 3x minus 2 a factor of this cubic function? The reason, by the way, this problem right here is the reason why I picked problem 75 from your homework to go over. Could I factor this by grouping? It's 4 terms, right? So couldn't I group the first terms and the second terms together? When I factor out, and you got to kind of visualize it, but if I factor out a greatest common factor, will I get the same thing in parentheses? Which means factoring by grouping is totally useless in this case. I can't do it. Which means instead of saying, well, I just can't do it, now we've got an option. You might have to use long division. Okay? So here we go. Let's go through the process. We always start with the highest degree term on the outside and the highest degree term on the inside. And what we're looking for is, what do I need to multiply the 3x by to get 6x cubed? 3x times what gives me that? 2x squared. There we go. There's your first part of your answer. First part of your quotient. Just like you did with the numbers, we then take that and we multiply it through the 3x minus 2. 2x squared times 3x gives you 6x cubed. 2x squared times the negative 2 gives you a negative 4x squared. And we subtract. Okay, just like we had the 28 minus 27, same idea. I'm going to give you a heads up. You don't have to follow this. I think it's probably a good idea. You're going to be subtracting these two. Notice there's kind of a lot of negatives and a minus sign. One of the things that I personally always do just to make sure I don't make a mistake, instead of subtracting what we just came up with, I'm going to add the opposite. The reason why I do that, now all you have to do is combine like terms. It cleans it up a little bit. Okay, so you don't, because if you add or subtract wrong someplace, especially in the beginning, everything after that's going to be wrong. So you got to be careful, okay, on your signs and on adding and subtracting like terms. So a lot of times I will add the opposite, so all I have to do is combine. What should always happen when you do long division? The first term, if you're doing it correctly, should always cancel. 6x cubed, negative 6x cubed. Those cancel out. The x squareds, when you put them together, give you a negative 12x squared. I put those two together. It was negative 4.
Yeah, then you
But
made
how
a
do you get the
positive
negative 6 if it's a positive 2? Because it's a positive 3x.
Hold on, let me go back.
Because you subtract.
Hang on. You missed it. It's okay. It's okay. Let me go back. When I multiply, it's okay. We'll get it. We multiply through. 2x squared times 3x gives me a positive 6x cubed. Okay? Times the negative 2 gives me a negative 4x squared, which then we are subtracting. Here's what you missed. When I subtract that bottom part, I'm going to actually add the opposite of that, which means this becomes a negative 6x cubed and that becomes a positive 4. All I did was distribute a negative through. Now I can combine like terms. Okay, like I said, you must have just missed it. Okay, which is fine. It happens. Okay. That's where then, when in the x squareds, I have a negative 12x squared. Okay. Now what do I do next? Yep, just like long division back in 5th grade. Bring down the next term. Bring down the next number. And we go again. Now we restart the process. We come back to the highest degree term on the outside. But now we're looking for, what do I multiply to get negative 12x squared? Negative 4x. There's the next part of your answer. Okay? Negative 4x. All right. And we take our next part of our answer, our quotient, and we multiply it through the 3x minus 2. Negative 4x, times that gives me negative 12x squared. Multiply by the negative 2. I end up with a plus 8x. And we subtract. Again, I'm going to add the opposite. Rather than subtracting that bottom line, I'm going to add the opposite of that bottom line. So that becomes a positive 12x squared and a negative 8x. And now we just combine like terms. Okay? Yeah, come on. That's where I did the negative 4x times the, that's where this positive 8x came from. Okay. All right. So once again, the x squared terms cancel out. The x's, when I combine, give me 9x. Now what do I do? Bring down the next term. Go again. We're close though, because this is the last term. What's the last part of my answer? What's going up top? What is it, Ella? Yep. 3x times what gives me 9x? Positive 3. 3 times 3x is a positive 9x. 3 times negative 2 is a negative 6. And what do you know? We end boom. We ended up, when we subtract, those cancel out. We get 0 as our remainder, which means, is 3x minus 2 a factor?
Yep.
So here's the last thing I want you to understand, because this is where we're headed. We started with this cubic function. And we said, I can't factor by grouping. We did just factor it. Here are your factors. Factor number 1 is 3x minus 2. Factor number 2 is your answer. Okay? So I could now rewrite this as 3x minus 2 is one factor. And like I said, the quotient, your answer that you got, is your other factor. 2x squared minus 4x plus 3. Okay. What's that? So this would be, so just as a heads up to clarify, make sure you're listening, please. Just to clarify, today when you're doing these long division problems, we're just practicing the process of long division so that next week we can use it. So technically the answer to this problem is the 2x squared minus 4x plus 3. Where we are headed is what we were just doing in the homework. Here's an equation. Find the zeros. Do all of that kind of process. Well, one of the zeros would come from right here because we just found out that's a factor. We'd have x equals 2/3 is 1 0. And then we would have to say, now let's try to factor a quadratic formula the next part to get the other 2 zeros. We're not going to do that today. Okay? You're not doing that today. That's next week. Today is just do the long division. Okay? Yeah, Eddie?
So, since we couldn't do factor by grouping the factor, how did we come up with 3x minus 2 to do division?
For now, I gave it to you. You will, for now, you'll just be given. Next week, we'll talk about where you start. That's a good question, though. Okay. All right, let's go example number 2 here. Let's try again. Oh, Mr. Rather. Well, we're doing long division, let me tell you. They're loving every minute of it. Yeah, no, I'm not. Addie loves it. She loves every day. But she really loves today. Yeah. Really loves it. I just told her my 5th grade son is doing long division right now. See, doesn't this look fun? Does this not look fun to you, Mr. Rather? As a former social studies teacher, does this not look enjoyable? That's what I thought. Yep. How we doing? Are you just stopping in, or you need something? Uh-oh. I'm recording this lesson too, just so you know. So this is all this is all going to YouTube. All right. Huh? Sure they do. 9x minus 6 and 9x minus 6. See, that's why we add the opposite. Negative 6, positive 6. You're subtracting a negative 6, so it's really adding 6.
So it's multiplying by a negative.
Yeah, basically. That's what I mean when I say add the opposite.
I thought that it was just that subtracted by that. I was like,
Yeah. No. You're multiplying the bottom one by negative 1. Okay, here we go.
Hold on, I didn't even get to do it yet.
Oh, what did I?
Give me like 2 minutes.
2 minutes. Okay, well, I'm going to set it up because I don't have 2 minutes today. We got to go. All right. If we set this one up, by the way, I don't know if you heard before, but Aiden had a really good question of where is the 2x plus 1 coming from? Where would we get that in the future? Like, what do we start with? Hold that thought. Right now, the answer is you'll be given it. Okay? They'll give you what to start with. Next week, we'll talk about where do you start when it's not given. Okay? But for now, you'll always be given the what to try. Okay? All right, here we go. 2x plus 1 divided by, here's this example where I talked about filling in with placeholders. 8x to the 4th. Do I have an x cubed term? Nope. Okay, plus 0x cubed. Do I have an x squared term? Nope. Plus 0x squared. Do I have a term that has x in it? Nope. Plus 0x. And then finally, I do have a constant. Minus 5 at the end. That's what I meant by placeholders. In this case, I had 3 of them that were missing. So I had to fill in with zeros. And now, process, yes, Evan?
If 8x to the fourth power was the only term that we were dividing by, would we still do all of it?
If it was just the 8x to the 5th, no, not really, because of the fact that it would kind of stop after that. But that's a good question. If that was the only term, then no, then you don't need it. Okay, here we go. Let's work our way through the process. 2x times what gives me 8x to the 4th? 4x to the 3rd. Okay. Come on, focus, focus. Unless you're working on the problem, focus. Okay? 4x cubed times 2x gives me 8x to the 4th. Multiply by the positive 1, I get 4x cubed. And we subtract. Or add the opposite. Okay? 8x to the 4ths, cancel. We end up with a negative 4x cubed. Okay? 0 minus 4. Okay? And now, we bring down the next part. 0 minus 4. Or if you don't like, again, if I continue with the add the opposite, 0 plus negative 4. Either way. Okay. All right, let's go again. What's the next thing going up top? 2x times what gives me negative 4x cubed? A negative 2x squared. Okay. Multiply that through our divisor here. Negative, multiplying by 2x, we end up with a negative 4x cubed. Multiply by the plus 1, and I get negative 2x squared. Here, by the way, is a really good example of what I was referring to. This spot right here is why I add the opposite. We got negatives and minus signs everywhere. And if we screw this up, everything after it is wrong. Okay? If we add the opposite, it all of a sudden cleans up. Now I just have to combine the x cubes, those cancel, and 0 plus 2 is 2. So we end up with 2x squared. Okay, that's the reason right there why I do it with adding the opposite rather than subtracting. And now we bring down the next one.
It's not squared.
Thank you.
It's just x on top.
Thank you for not letting me screw up the rest. I appreciate that.
That's right. Well, it's 'cause I don't know the last step, so we can't get there.
Now we keep going. What's the next thing going up top?
X.
Yep, 2x times x gives you 2x squared. Multiply it through, we get 2x squared. Multiply by the 1, I get x. And we subtract.
Negative x. Wait, yeah, what happens now?
Hang on. So now, 2x squareds cancel. 0 minus x gives you negative x. And we still bring down the minus 5. Hang on. All right, last question in terms of the long division here. It's not the nicest thing, but 2x times what gives me negative x? Negative half. Okay, so we come back up here and we put it as negative, either negative 0.5 or a half, 1 over 2, doesn't really matter. I don't care how you write it. And we multiply through. We get negative x when I do that. And then we get negative a half. So, again, here's a whole bunch of, notice every single one here has negatives and a minus sign. Too much going on there. Add the opposite. Combine like terms, the x's go away, and the constants add to negative 4.5. Which in this case tells me we have a remainder, which also tells me 2x plus 1 is not a factor of 8x to the 4th minus 5. Okay? That was not a waste of time. Do you see how much learning happened here? Oh, it was a disappointment. It was not a waste of time. Okay? All right, let's keep going. What do you mean, wait? We got time. We got 7 minutes yet.
Wait, so it's not, oh, you say that it's not a factor?
Yeah.
Okay,
All right, so long division, it's a long process. There's absolutely nothing I can do with that. That is just the process, okay? And just a heads up in advance before we get into synthetic division, the shortcut. Synthetic division isn't always going to work. There will be problems you have to do by long division going forward, which is why we covered it. There's some times where you have no other options but long division and you're going to have to do it that way. So don't avoid it. Okay? This is what I'm telling you. Don't skip through it. Don't avoid it. Understand it so that you can do it. Work your way through it. I'm not giving you a lot of problems of long division today. So, yeah.
Is there a way to tell that if you're not using synthetic division?
Yeah, we'll get to that next week. Yeah. For now, today, what we are doing is practicing long division and practicing synthetic division. We'll use it next week. Okay? All right, here we go. Synthetic division is a shortcut if your divisor is kind of in the form x minus something. X minus 2, x plus 5, x whatever you happen to have. Okay? And the idea behind synthetic division, here's the major difference between the two. In long division, we divided by the factor that we were checking. Okay? The 2x minus 3 or the 3x minus 2 or whatever it was. In synthetic division, you use the 0, not the factor. Okay? You're going to use the 0 for synthetic division. You still have to keep in mind that if there's any missing terms, we still got to use the zeros. We got to put placeholders in there. Here's an example for you. We'll do one example of synthetic division, and that'll take us to the end. I have a second one, but we don't have time, and I think you'll have it anyway. Okay, here we go. So again, we have a cubic function. We're trying to figure out if x plus 2 is a factor of that function or not. But we're not going to do the long division on this one. So here's step number 1. If x plus 2 is the factor, what's the 0? Right? That's what we use for synthetic division. We use the 0. Okay? Negative 2. You remember doing this last year? Okay. The nice part about synthetic division is it takes out all the variables. Okay? So here's what we have. 5x cubed, we're just going to use the 5. Notice, we're missing the x squared term. It's gone, which means we need to put a 0 in there as a placeholder. We have 6, and we've got 8. Okay? Here's the process. As you work your way through, step number 1 always is bring the first number down.
4.
And now we have a 2-step process that we just keep repeating. Take that number, multiply by negative 2. I get negative 10 as an answer. And then we add. 0 and negative 10 give me negative 10. And then we go again. Multiply. We end up with positive 20. Okay, negative 10 times negative 2. And then we add. 26. And then we multiply. Negative 52. And then we add. That final number that I put in the box is the remainder.
I like that way better.
It's a hair quicker.
Just a little bit.
Just a hair quicker. Okay? Now, here's what you just found, because right now this is just a whole bunch of numbers. Negative 44 is the remainder, which tells me x plus 2 was not a factor. But let's pretend that it was. Okay? Remember, division is a method of factoring. So let's say that ended up, don't put that away yet. Just wait, I'm not done. I heard you say earlier. Here's what, if we got a 0, here's what you found. Here's how this helps. Negative 2 we said was the 0. Therefore, x plus 2 is the factor. Coming from there. All the numbers on the outside are your factors, basically. Here's the idea. We started with a cubic function. Every time you do synthetic division, the numbers below the line are the coefficients of 1 degree less. Which means, if that was a 0, if this was a factor, the other factor would be 5x squared minus 10x plus 26. If that was a 0, okay, it's not, and there would be your factored form, okay? I'll leave the other one for next week. Here's the assignment for today. Shoot is what you meant. Shoot. Darn. You have a total of 7 problems. I think 3 of them are long division and 4 are synthetic. It's 3 and 4. I just don't remember which one. Practice the division. All right, and have a good weekend.